Using tree diagrams for probability problems without replacement. So oftentimes we have probability problems that are a bag or a box of marbles or pom-poms or counters or something, and you're drawing some out. This example is going to be when you do not put your first one back in. So we would call that without replacement. So I have a bag of pom-poms, 3 white, 4 colored. I pick one pom-pom out, and without looking, I do not put it back in the bag. Okay, so I might set it aside, I might record it, right? But I'm not putting it back in the bag. Then I pick out another pom-pom. So what's the probability that I pick out a white pom-pom and a colored pom-pom in either order? The trick is this time our sample size is going to change from our first draw to our second draw. So on our first draw, we just look at what we have in the bag. So I have 3 white out of 7 total. So I'm going to write 3 over 7 right here on this first branch. There's 4 colored ones, so I'm going to write 4 out of 7 on this branch. Here's the gotcha. I set that aside. I do not replace it into the bag. Now I'm going to pull out a second pom-pom or counter or marble or whatever you want. And I'm going to pull it out. Now, remember, I took one out already. So instead of having 7 in the bag, I only have 6 in the bag. So my denominators on all of these branches are going to be 6. So if on the first draw I pulled out a white pom-pom, then I only have 2 white pom-poms left. So now my probability of getting a white one on the second draw is 2 out of 6. I still have 4 colored ones, so I would write 4 out of 6 on this line. I could compute those probabilities right now. I could write 3 out of 7 times 2 out of 6 for this first outcome. And for the second one, I could write 3 out of 7 times 4 out of 6 on this second one. But let's go back and fill in the rest of our tree diagram. What if on the first one I pulled out a colored pom-pom instead of a white one? Well, on the second draw, I would still have 3 in the bag. So I would get 3 out of 6 on this line. But down here on this bottom branch, since this is connected to I pulled out a colored pom-pom on the first one, now I only have 3 colored pom-poms, so I would write 3 out of 6 on this branch. Then I can go ahead and calculate those probabilities. So I hope you see that this was what we would call a dependent multi-stage event, because what happened on the first draw affects what happens on the second draw. So let's take a look at our answers. There's our whole tree diagram filled in, and you can see that we multiplied 3 over 7 times 2 over 6 and got 6 over 42. So our sample size changed from the first draw to the second draw. And now we can answer the question, what's the probability that I pick out a white pom-pom and a colored pom-pom in either order? Well, it's going to be these 2 middle outcomes here, where it is a white one first and then a colored one, and then this outcome is a colored one and then a white one. Notice they both end up being 12 out of 42. So I'm going to add those 2 outcomes. 12 out of 42 plus 12 out of 42 is 24 out of 42, which would simplify to 4 over 7. I hope that helped you see an example of using tree diagrams on an example that would be considered dependent multi-stage, so without replacement. Thanks for watching.